Okay, so in this part, what will happen? This is concept of dearrangement. Dearrangement means suppose that you have you have some envelopes. Okay, means suppose you have invitation letter. So invitation letter will be placed in corresponding envelopes, correct? So letter A will be given to envelope number A. Okay, letter B will be placed in envelope number B. Okay, so this is arrangement. So suppose that I have given you to arrange things and now you are thinking so much. Okay, so what will happen? You may feel that, sir, I have to do this work correctly. So in how many ways we can do it in correct way? So you know that there is exactly one way to complete this task in correct way. Means A will be placed in A. So for A, one choice. For B, one choice. For C, one choice. For D, one choice. Means to do this task is only one way correctly. But what if we are doing this thing incorrectly? So there are how many ways? So you know that we cannot put letter number A to envelope number A, but we can put it in B, C, D, E, F, and so on, so forth. Correct? So this concept we will be studying in dearrangement. Okay, suppose that you have five letters and five envelopes. So how many dearrangement is possible? So you can answer that question by using formula of dearrangement dn. So the formula goes in this way: n factorial by 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial, and you will keep on going this till the time you get denominator as n factorial. So this is the arrangement of n objects. Okay, now let's try to solve some questions for better understanding. Now look at this. 6 cards and 6 envelopes are numbered 1, 2, 3, 4, 5, 6, and the cards are to be placed in the envelope so that each envelope contains exactly one card. Okay, then question number 1: all cards in correct envelope. So you know that you have to do this task in correct way. So there is only one way to complete this task. Correct? Now, no card is placed in its corresponding envelope. So we have to dearrange all these 6 cards into 6 envelopes. So can I write D6? So in place of n, I will be placing 6 and then we will get the answer. Okay. Now look at this. Exactly 3 cards are placed in correct envelope. Okay. So 3 cards in correct envelope and 3 cards in wrong envelope. So what I will do, first I will select 3 cards which has to be placed correctly. So there are 6 cards available, out of which we will be selecting 3. So 6C3. Now these 3 cards has to be placed correctly, and we can do this task by only one way, that is 1. Our task is not completed because we have to handle 3 more cards, and those 3 cards has to be placed incorrectly. So we have to dearrange 3 cards. So can I write D3? Okay, I hope this is clear. Now look at question number 4. Exactly 4 cards wrongly placed. So don't you think you can connect this question with the previous question? Like, you have to place 2 cards correctly. Hai. So what we will do, we will select 2 cards out of 6 cards and we will place them in correct way. So there is only one way to do this thing correctly. Now we have 4 cards and these 4 cards has to be placed wrongly. So we will go with D4 ways. Okay, I hope this is clear. Now look at this question. If no card is placed in the envelope bearing the same number, moreover, the card 1 is always placed in envelope 2. Okay, so you know that there is card 1, card 2, card 3, card 4, card 5, card 6. Correct? Now, you know that to dearrange everything we need D6 ways. Correct? So, suppose that we have dearrange everything. Now, the idea is they have restricted card number 1 to, to be placed in envelope number 2 always. So can I say that D6 is containing all the ways in which the card 1 is placed in card number 2, card number 3, card number 4 and card number 5 and card number 6, and those number will be equal. The number of ways in which card 1 is placed in card number 2 will be same as placing card 1 in envelope 3, is same as placing card number 1 in envelope 4, is same as placing card number 1 in envelope 5, and it is same as placing card number 1 in envelope number 6. So it is equal in number. So how many possibility are there? So 5 possibility are there. So if we will divide by 5, don't you think we will get the total exact number of ways in which card number is placed in card number 2 or 3 or 4 or 5 or 6? Means it was equal na. So we will divide by those number of distribution. Okay, so we will get exactly the number of ways in which it is being placed in the specific card. Okay, I hope this question is clear. Now let's move on to this question. The number of ways that can be, the number of words, okay, the number of words that can be formed by rearranging the letters of the word COVID, okay, such that no letter is in its own place. So it is question of dearrangement. Okay, and word should not start with the vowel. Okay, so first try to dearrange things. So you know that dearrangement will be done in D5 ways because there are 5. All letters will be placed in equal number of ways. Okay, so I am asking you, the exact letter in exact envelope will be done in D5 by 4 ways, है ना? You can go with dn by n minus 1. Okay, this will give you exact number of numbers in which particular card is placed in particular wrong envelope. Okay, now look at this. They do not want word to start with vowel. Okay, so C O V V I and D. Correct? So this means what? The word should start from consonant. Okay, so there are 3 consonants. Okay, so the number of words that can be formed by rearranging the letters of the word ठीक है, own place. Word should not start with, okay, word should not start with M. Vowel is M. So look at this. So your word should start with consonant. So either C, either V, or either D. But look at this. C, if you will use C, C will be placed at its own place. So that is wrong. Okay. So what we will do, we can start with V, we can start with D. So there are 2 ways. Okay, so the number of words that is starting with V will be D5 by 4, and the number of words which will start with D will be D5 by 4. So this is your M. Now you can calculate M by 3. Okay, I hope the idea is clear.